So we are going to dive right into section 4.5. And before we do that, we really want to feel comfortable identifying or how to identify a greatest common factor. That is going to be key to this module and key to factoring. So first of all, the real basic question, what is a factor? So a factor is just basically two numbers or two variables or a number and a variable being multiplied. So 3 times 2, 6x, x squared times y. Those are all examples of factors. So 3 is a factor, okay? And 2 is a factor. You multiplied them together, and then you would get 3 times 2, you'd get 6. 6 would be the product. So the way that you find common factors between multiple integers is, I'm just going to give you one way. And this method will work really well, especially if you're not super comfortable with, multiplication facts. Maybe they're a little fuzzy. So you're just going to break each integer down into its prime factors. So prime factors are going to be the lowest level of numbers you can multiply together to get that product. And then you're going to identify the factors that are the same. Okay, how does this work? So let's look at this first example. We're going to find the greatest common factors between 21 and 15. Okay, so another way of saying that is what number can divide evenly into both 21 and 15. That's another way of thinking about a greatest common factor. But let's go ahead and take 21. Take any two numbers you can multiply together to get 21, except you wouldn't want to do 1 times 21. That's not really going to help you. So pick another number. How about 3 times 7? 3 and 7 are what we call prime factors because you can't break them down any further except into 1 times that number. 1 times 3, 1 times 7. That's all you can multiply to get 3 and 7. So that's why we say those are prime. Now for 15, we can do 3 times 5. Those are its prime factors. So you can clearly see that 3 is the same factor between both for 21 and 15. And so we say its greatest common factor is 3. 3 is a number that divides evenly into both 21 and 15. That's why it's its greatest common factor. All right, let's go ahead and look at two numbers that maybe aren't as obvious for some people, 42 and 96. So I'm going to start with the prime factor tree. You can start with any two numbers that you can multiply to get 42. For me, I think of 6 and 7. 7 is prime, so I'm going to circle that. I don't have to go any further. 6 is what we call composite, meaning I can break it down further. I can break it down into 2 times 3. 2 is prime, 3 is prime. So the prime factorization of 42 is 2 times 3 times 7. If I multiply those 3 numbers together, it gets me back to 42. Let's take 96. Now, 96 is a larger number, and so people might not be as familiar with what two numbers you can multiply to get 96. So here's what you can do. Look and ask yourself, is this an even number? Well, it is. So that means I can multiply 2 times something to get 96, okay? So 2 goes into 96 for 48 times, all right? So 2 times 48 gives me 96. Let's go ahead and take 48. You could do 2 again. You could do 2 times 24, okay? My 2's are prime, so I'm not breaking them down. Let's do 24. 2 times 12, and then 12. 2 times 6, and then 6. 2 times 3. So I have 1, 2, 3, 4, 5 2's. I'm going to write that as an exponent, 2 to the 5th times 3. That is going to give me my prime factorization. Well, I can see when I look at this that the 2 and the 3 are common to both of those prime factorizations. And so that means my greatest common factor, I could say 2 times 3, but I'm just going to say 6, okay? 6 is the greatest common factor. All right, now let's look at the common factor between variables. How do we find that? So, first of all, when you're looking at different sets of factors, a common factor needs to be present in all, in this case, I'm going to look at 3, those 3 expressions. So when I'm looking for my greatest common factor, my factors need to be present in all 3 of those expressions. So let's first look at the x's. I've got an x, an x, and an x. So now what we're going to do is we are going to select the variable x, and then we're going to pick the exponent that is the smallest. So that's going to be x to the first, okay? That's x to the 1 right there, or just plain old x. Then when I look at my y's, I've got a y, but right here, no y. So that means I cannot have a y in my greatest common factor. So my GCF is simply x. All right, so let's look at the next one. I'm actually going to go ahead and apply the exponent of 2. So we've got x squared, y squared, z squared. So I look and I see an x present in all 3 of those expressions. So x, and then the smallest exponent is a 2. Now let's look at the y's. I see that there's a y in all of them. My smallest exponent, again, is a 2. And then I look at a z's. Z's are present. My smallest exponent is right here in the middle expression. It's a 1. So x squared, y squared, z is going to be my GCF. Now let's just kind of put it all together, where we've got numbers and variables all in the same expression, okay? So the first thing is I'm going to look at the coefficients, all right? And I'm going to do that first. And so for this first example, I look at the 6, the 9, and the 15. So some of you will look at that and say, oh, well, 3 divides evenly into all of those. And you're done. You're done. If you can see that, you don't need to break it down into prime factors, okay? But some people can't see that. So with the 6, I see 2 times 3. The 9, I see 3 times 3, which is, I'm going to write that as 3 squared. And then the 15 is 3 times 5. So when I look at this, just like I did with my variables, I see that I have a 3 that is common to all 3 of those expressions. The smallest variable, the smallest exponent of those 3's is 3 to the first. Yes, I have a 3 to the second, but just like when I was looking at the variables, I pick the factor that's common that has the smallest exponent. So that'll just be 3. Now I look at the x's. There is an x present in all of those, but x to the first is the smallest. Same with the y's. All right, so now let's do the next example. where we've got these three expressions that I just highlighted in yellow. And so you are going to look for what number can divide evenly into all three of those coefficients. If you don't see that number, then you can break this down into its prime factors. Okay, and so I guess we can do all the way down. And 20 would be 4 times 5, 2. Okay, so for 12, I've got 3 times 2 squared. Then I've got 2 to the 4th and 2 squared times 5. So 2 is clearly common to all three of those. But the exponent that's the smallest is 2 squared, which is the same thing as 4. Now let's look at the variables. I have an x that's common to all three. X to the first is my smallest. Then I look at my y's. My y is missing from that middle expression, so it cannot be part of my common factors, okay, because it's not present. It needs to be present. A y would need to be present in all three. All right, so now let's go ahead and move on. So when we are factoring out a greatest common factor, first thing we're going to do, identify the greatest common factor of all the terms in that polynomial. Next, we're going to write each term as the product of the GCF and another factor. Then we'll use the distributive property to factor out that GCF. Okay, so first thing we want to do, identify that GCF. So I look at, here's a term, here's a term, here's a term, here's a term. So I look at 8, negative 20, negative 12, negative 20. Ignore the negative part for right now. And I can see that 4 divides into all of those evenly. So if you can see that right away, you're good to go. If you need to break it down into its prime factors, do that. Not a big deal. Then I look at my variables. I see that there is an x that's present in all of those. So the smallest the smallest exponent is x cubed. So 4x cubed is going to be my greatest common factor. So I'm going to write that out front, followed by a set of parentheses. Now, when I take that greatest common factor, you can either do this in your head or you could write it out. So I can go ahead and write 4x cubed underneath each of these terms. And when I actually simplify each of those terms with that greatest common factor, my result is going to go in the parentheses. So 8 divided by 4 is 2. X to the 8th over x cubed, that's using my my integer property, so quotient with like bases, and so that'll be x to the 5th. I just subtract 8 minus 3. Now I've got my minus. I do the same thing with my next set. So that's going to be 5x cubed. Now I go to my third term, minus, and that'll be 3x. X to the 4th over x cubed is just plain old x, minus 5. We're done. This is referred to as the factored form. Okay? I could check that by going ahead and taking that pink greatest common factor, multiplying it times each of the terms that is in my, right here in my parentheses, and that'll take me right back to my original expression. All right, let's look at the second one. So we're going to start by finding a GCF. So when I look at my coefficients of each of those terms, I have a 1 that's implied in front of that y cubed, 13, 11, and 19. There are no common factors of those coefficients. So now let's go to the variables. I have a y that's present in all of them. As a matter of fact, y to the first has the smallest exponent. Then I look at my n's. I don't have an n in that first term, so it cannot be part of my greatest common factor. So my greatest common factor is y. So I can just in my head divide each of these terms by y. And now when I do that division, okay, I'm going to be left with y squared minus 13n cubed plus 11y to the fourth n to the seventh minus 19y squared n cubed. This is my factored form. The factored form must include the GCF in front and then the result after you divide each of that original terms by that GCF. That's what falls into the parentheses. Okay, you try this third one. Press pause, try it, and then compare your answer to mine. So for this one, you should have gotten a GCF, which is 6x to the fourth y cubed z squared. So we put that out front. You always have your GCF out front, 6x to the fourth y cubed z squared. Inside of your parentheses, you will have 5y cubed minus 2x cubed z squared. All right, now let's move forward and look at what happens when our leading coefficient is negative. Okay, so when the first term is negative, then we factor out a negative GCF. We don't like to have our leading term be negative. All right, so here we go. Let's find our GCF. So for this first one, I see that I have a negative there. So I know my GCF is going to be negative. Now, kind of ignore the negative for a moment, and let's look at 3, 12, and 18. Is there a number that divides evenly into all three of those? Of course, it's 3. So negative 3 would be my GCF. I don't have any variables that are common to all three of those terms. So I'm going to take that greatest common factor, negative 3. Now it is followed by parentheses. So I am going to go ahead and divide each of these terms by that negative 3. When I do that, okay, my division is going to be, my first term is a positive x squared, because a negative divided by a negative gives me that positive x squared. Now I've got minus 4x and then plus 6, and that's all. This is going to be my factored form. The only reason I wrote that negative 3 underneath each of those terms was so that I could make sure that I got my signs right. All right, let's do example number 5. We look for our GCF. So for this one, I don't see all I really see right here is a negative as my leading term. So I know my GCF is going to be negative. I've got -1, 9, 21, and 18. So there are no numbers other than -1 that would be my GCF. There's not a common y because that 18 does not have a y. But because my leading term is negative, I at a minimum need to take out a -1. Well, here's a cool thing. When you are factoring out a negative GCF, all it does is it flips the sign of every one of your terms. So this negative y squared, it becomes a positive y. I'm sorry, y squared I said, but I meant y cubed. It becomes a positive y cubed. That positive 9y squared becomes a negative 9y squared. Then I've got a minus 21y and a minus 18. That's done. Now let's just pause a minute, go back to number 4. Let's see if the same thing happened when we factored out a -3. So we went from a negative to a positive. We went from a positive to a negative and a negative to a positive. So yeah, the same thing happened. All the signs flipped. Okay, so pause, try number 6, and then hit play. So for this one, our GCF is going to be a -5u. So if we take out a -5u, okay, then that is going to give us, it's going to flip the signs, so a positive 3u cubed. If that's hard for you to see, do not worry about putting it under there, just writing your GCF under that term. And then maybe you're more visual learner and then you can see it. The next one, that -10u, we flip the sign. It's going to be a positive. When we divide by 5u, we're left with 2u squared. That positive 25u, it's going to be a negative term. As a matter of fact, a -5. There we go. That is now factored form. All right, you try these rather quickly, and I am going to just go ahead and I will write in the answers for you. You can pause them, try them, and then play. So for this first one, you should have gotten 2a times a cubed plus 4. For the next one, our GCF is a 5, no variable. So that would give us x cubed minus, x cubed, but I wrote squared, minus 2. For the next one, our GCF is going to be 5c d squared. So that's going to give us 2c squared minus 3d. For the next one, we have a leading coefficient that is negative. So that means we need to take out a negative. And so that's going to be, in this case, our 8 is the highest or the greatest number that you can divide into 32 and 24. So -8y. And then we are left with a positive 4y plus 3. How did this next one? Again, we have a negative leading coefficient. So we take out a negative 2, so we're left with x minus y. And then for the last one, we can take out a GCF of 2d to the 5th, so we're left with 5d squared, and then plus 1. Okay, let's move on and factor out a binomial factor. This looks really strange at first, but you'll catch on rather quickly. So what we have here is a term and then another term. And so when you're factoring out a greatest common factor, you are looking for within the terms what is the same factors. Well, when I look at this, I clearly see that the 2x plus 3 is the same between each of those terms. It's the same factor because it's being multiplied times either a number, it's being multiplied times something else, okay? So let's go ahead, and our GCF, strangely enough, is going to be that 2x plus 3. So I'm going to go ahead, pull out the 2x plus 3. I'm going to put parentheses around it because that's how my factor is presented. So I'm going to go ahead, show you that if I put it underneath to divide into each of those terms, whatever is left over is going to come into the parentheses, just like we were just doing. So in that first term, the 2x plus 3's reduce, and I'm just left with 5x. In that second term, the 2x plus 3's reduce, I'm left with minus 2. This is referred to as the factored form. Okay, let's go ahead and look at the next one. So, same thing. I've got 3 minus m, which is the same to, which is a factor present in each of those terms. So my GCF for this one is going to be 3 minus m. If I divide both of these terms by 3 minus m, let's see what happens. So I first write my GCF. It is followed by a set of parentheses that after I reduce, that whatever is left after I reduce goes into the parentheses, so 5m. Plus, for the second term, it would be 9n. There we go. That's my factored form. Now, let's look at number 9. Number 9 is a little bit tricky, okay? So with this one, it looks like y minus 3 and 3 minus y are basically the same, but they're not. Subtraction is not commutative. You cannot switch the order of subtraction. It will give you the opposite result. Okay, so let's just take that second set of parentheses. All right, let's take 3 minus y. And let's change that to an addition problem. So that's going to be 3 plus a negative y. Those are the same statements. Now let's go ahead and reverse the order of that addition. So that's going to be negative y plus 3. Well, this negative y can be factored. that expression can be factored, and we don't like to have a negative as our leading coefficient. So I'm going to factor out a -1. Now that will flip the signs of each of those terms. So that becomes a +y and a -3. Well, look at this. So now I've got a y -3 and a y -3. So I can take and substitute for that 3 minus y. I can substitute this whole thing. So we're going to go ahead and substitute this -1 times y -3 in for that 3 minus y. So let's just go ahead and bring down the 4c, and that's not being subtracted, that -1 is being multiplied times 4c. Bring down the plus, bring down the 2x, y -3. Okay, so now we have a common factor. We also have a common factor between the 2 and the 4. So our greatest common factor is going to be 2y -3. Then what is left over? X, okay? Then minus 2c. There we go. So that would be our final factored form. Okay? All right. You try these next ones. So out of these two, for A, you're going to take out a y plus 2, and then you're left with x squared plus 5. Then out of the second one, you don't have to do the long way that I did. All you need to recognize is that w minus 9 and 9 minus w are like in the opposite of what you would like. So in order to get them to be common, to be the same, you take one of them. I'm going to take the second one here, and that is going to be the same as -1 times w minus 9. It's exactly the same. So I'm going to just substitute that in. So now we've got, oops, not a 2, a z, w minus 9 plus 2 times -1 times w minus 9. So I can take out the w minus 9, that's my greatest common factor, and then I'm left with z minus 2. There we go. All right. So now we're going to learn a new technique for factoring. So the first technique was just factoring out a greatest common factor. And you always, when you're looking at factoring, you want to always look for a GCF. Second is a strategy, factoring by grouping, and you use this strategy when you have a 4-term polynomial. So the first thing you do is identify and factor out the GCF. Your second step is you factor out the GCF from the first pair of terms and usually a different GCF from the second pair of terms. If the two terms share a common binomial, then you factor out the binomial, just like we were just doing. So it's like you factor twice. All right, so let's look at this first example. So I see that I have 1, 2, 3, 4 terms. So I am going to put parentheses around the first 2 and the second 2 terms. So now I'm going to just focus on this first term, and I'm going to take out my GCF. So I'm going to take out a 5x. So then I am left with 4x minus 5y. Out of my second pair, I'm going to take out a GCF. That one, I can take out a positive 6y. And so then I am left with 4x minus 5y. What will usually happen is these binomials are going to be the same. And so I can pull that out. That is my greatest common factor, just like we were just doing, 4x minus 5y. Everything that's left over, so the 5x and the plus 6y, goes in the parentheses following that GCF. This is now in factored form. Okay, let's try 11. So first thing that I'm going to do, put parentheses around the first two and the second two pairs of terms. Next, I am going to, out of the first pair, factor out a greatest common factor. In this case, it's just x squared. And then I'm left with x minus 5. Out of my second pair, I'm going to factor out a GCF. In this case, it is a 4. And I'm going to be left with x minus 5. My binomials match. So I factor out that common binomial, which is my greatest common factor, and everything that's left over, the x squared and the plus 4, follows. Now that is factored. I could check this, just as a reminder. I could multiply that x minus 5 times x squared plus 4, and it'll get me right back to my original polynomial. Okay, number 12. Number 12 has a red flag in it. So when you look at your third term, if your third term is negative, what you want to do is you want to change that subtraction to addition. Not a problem. I'm going to change that to addition and put my negative with that third term. You want to do that before you use grouping, before you put the parentheses around. So there I'm grouping my first two terms. I'm grouping my second two terms with that addition sign between the two. Now I can go ahead and I can factor out from my first pair. So that's going to be x squared, x plus 8. Out of that second pair, I see that I've got my leading coefficient is negative. That's a negative 5. So that means my GCF is going to be negative. In this case, it actually is a negative 5. So if I divide both of those terms by a negative 5, I'm left with positive x plus 8. So now my binomials match. That becomes my next greatest common factor, x plus 8, followed by everything else that's left over, x squared minus 5. That is my factored form. Okay. Let's do one more example of these. So we've got a third term, which is negative. So I am going to change that to addition, make it plus, and put the negative with that 16. Now I feel comfortable putting parentheses around the first two and the second two terms. Out of the first terms, okay, the first pair, I can take out a 5x cubed. So that I'm left with 4x cubed minus 3. Out of that second pair, I can take out a negative 4. And so then I am left with a positive 4x cubed minus 3. My binomials match, so I'm going to pull out a 4x cubed minus 3, and then everything that's left over would be 5x cubed minus 4. Okay. You go ahead and try these next three. So that is going to give you, hang on. All right. So for this first one, I'm just going to go ahead, put parentheses. Out of the first set of parentheses, remove a 2x, and then you're left with 6x squared plus 1. Out of the second set of parentheses, you're going to remove a negative 5, and you're left with a positive 6x plus 1. So then your final factored form would be 6x squared plus 1 times 2x minus 5. And I forgot to mention, if you have your parentheses in the opposite order, so if you have 2x minus 5 times 6x squared plus 1, they are the same. Not a problem. All right, for B, your answer there, you're going to take out a greatest common factor first. Take out a 3. And then you are going to, when you take out the 3, you would be left with a 21x cubed plus 18x squared. I'm going to change that to plus a negative, and that's going to be 3 goes into 10, 3 and 1, 5, 35x, and then minus 30. All right, so now you can go ahead and put parentheses around, inside of the parentheses, around the first and the second two terms. And so we are going to be left with, you've got the 3 in front. So out of that first one, you can take out a, we'll take out a 3x squared. And so you're left with 7x plus 6. And then out of the second one, take out a negative 5. And so you're left with 7x plus 6. So then your final factored form is 3 times 7x plus 6, 3x squared minus 5. Now for the last one, that one is going to be, again, change that subtraction to addition, put the negative with that third term. You can take out a 4y squared, so then you're left with y minus 3. Out of the next one, you take out a negative 5. You've got y minus 3. So your final factored form, y minus 3 times 4y squared minus 5. So